So ULA has a role in the upcoming Parker Solar Probe that NASA is going to be launching to gather data about the sun. Describe that.
Yeah, that's an incredibly interesting mission. You know, it's actually being launched on a Delta IV.
Okay.
So we're using not an Atlas V, but the Delta IV rocket that we have as a part of our fleet. And for the Delta IV Heavy, it is actually the most powerful launch vehicle in the world. And it takes a lot of energy to launch that Parker Solar Probe satellite into that very tight orbit around the sun. So the Heavy mission is the only one that's capable of doing it, and that's why we're using that vehicle. For the Parker Solar Probe mission, the satellite itself is actually pretty small. It's about the size of a Volkswagen, so a fairly small payload on top of a very large launch vehicle. And that rocket will be launched on the 11th of August, and its mission is to really get in and start to explore the sun in ways that we've never explored it before, be able to help us understand those systems, rewrite the textbooks on our understanding of the sun.
So United Launch Alliance, with missions like this, has a great track record. Satellites, military missions. I think it's almost a perfect record recently, knock on wood. Why? What is it about the way your partnership with this company has operated that makes that happen?
So ULA has a very long heritage and history that actually goes back to the 60s for the Apollo program and Mercury program. The first astronaut was launched on an American astronaut was launched on an Atlas rocket in '62. It's John Glenn. And there is no secret to mission success. It is hard work. It's process, procedure, discipline through every step of what it takes to launch that rocket to make sure that every system is verified perfect and ready to support.
You touched on something a moment ago about the Delta rocket, its power, and the size of the Parker Solar Probe. Again, I think you mentioned that the Delta rocket, or at least I learned that it's the most powerful rocket in the world at this point. Describe again the need for that energy or that speed or power to take this relatively small payload on this kind of a mission.
So to actually get a payload into the sun, you have to overcome the force that wants to throw it away. And so it takes a lot of energy to push that payload in that direction. Otherwise it wants to stay in the orbit it's in now, which is the orbit of the Earth. And so we have the Delta IV Heavy vehicle produces 2.5 million pounds of thrust at liftoff, and we have a very powerful upper stage as a part of that rocket to give it even more energy to push it into the sun and create this very tight orbit around the sun and Venus that allows it to take even more energy out of the Venus flybys to get it even closer to the sun. So the physics of being able to get to the sun requires you to have that level of energy for that size of a payload.